A question from alcohols, phenols and ethers. The following is not an appropriate reaction for the preparation of tertiary butyl ethyl ether. C2H5ONA plus this is CH3 thrice CCl giving tertiary butyl ethyl ether. So they say it is not an appropriate reaction for the preparation of tertiary butyl ethyl ether. What would be the major product of this reaction? So we know that according to Williamson synthesis, an alkoxide is treated with an alkyl halide, or a sodium alkoxide is treated with an alkyl halide, and you get an ether. But a condition was there that the alkyl halide, here this is the alkyl halide, it has to be a primary alkyl halide, either a methyl or a primary alkyl halide. But here we can see that it is a tertiary alkyl halide. So what would be the major product of this reaction? Will we get an ether? So let us see. Say answer of the first question, that is C2H5ONA. This is our alkoxide, sodium alkoxide. This on treatment with this alkyl halide, this is tertiary alkyl halide, CH3, and this is Cl. So when we treat this, or when we react these two together, what will we get, or what will happen? This is a strong nucleophile. Not only is it a nucleophile, this alkoxide ion, it is a strong base also. It will come and take up a proton from here. So instead of CH2, CH3, you will be left with a CH2. That is, one hydrogen will be taken up by this C2H5O minus. It will take up a hydrogen from here. And as a result, this chlorine will go with sodium, and you will be having, say, CH3. Here you have a CH3, and here you will be having a double bond with a CH2 like this. So this, you can see, is an alkene. There's a double bond here and you have an alkene. So we have to name this alkene. We are asked to find the name of the product. So how many carbons are there? 1, 2, 3. And so on second carbon you have a methyl group. So we can write 2-methyl, then prop 1-ene. So this is an alkene. So what happened here was that we did not use a primary alkyl halide. We used a tertiary alkyl halide. So this happens via SN2 mechanism. So it does not favor tertiary alkyl halides. It favors primary alkyl halides. And as we saw here, we know that this is a strong base also. So this will take up a proton from here. And so this is alpha carbon and this is beta carbon. So beta elimination of hydrogen takes place, or beta elimination reaction predominates over substitution, and as a result you ended up with this alkene. And the second answer is that write a suitable reaction for the preparation of tertiary butyl ethyl ether. Let us change their places. That is, let us make this the alkoxide ion. Alkoxide, sodium alkoxide. So we will have CH3 here, then CH3 here, CH3 and O Na plus C2H5Cl. When we do this, here you have the alkoxide. This will come and attack here and the sodium chloride will be removed. So what will you get? C, here CH3, here also CH3, here also CH3 and O C2H5. So what is this? This is tertiary butyl ethyl ether. So here we used this as the alkoxide and this as the alkyl halide. We can see that this is a primary alkyl halide.